Okay, let us start. Can anyone confirm I am audible or not? Am I audible? Guys, please respond. I am audible or not, otherwise I cannot understand. Okay, thanks, Ravi. Okay, we have already done this live session one. In the same way, we will go through the different contents already covered in your uh, in your module two. Uh, And then after covering things over there, we will move to the question and answer part. And this time I have changed the question. So yeah, we have to do a bit of, uh, there are numericals and theoretical, both the things are there. Anyhow, so what have been covered in this module two or the earlier week is we have covered the different kinds of nomenclature and different kinds of symbol of welding joints. So how you should interpret any kind of welding symbol that have been covered, what kind of joint it is, what kind of specification, what kind of processes, uh, those things can be interpreted from a welding symbol. And then we have covered different kinds of power sources, the mechanism, and AC/DC power source, when you should use direct current, uh, positive polarity, when you should use the reverse polarity, DC, PDC, and those things, when you should use DC, when you should AC. So those things have been covered in those lecture videos, right? So we will go through again one by one in terms of concept, and yeah, obviously this will be very brief in nature because of time constraint. Anyhow, so let us start from this welding symbol. Okay, so if we talk about this welding symbol, how will it in general look like? So let's say you have a reference line like this, and you will have a arrow kind of thing, right? So there will be two sides of that welding symbol. One is called arrow side of the joint. So this is my arrow side of joint, and what the other side called? That is called far side. So one side is called arrow side, another side is called far side, right? And then if you want to mention any specification for your weld geometry, you have to put some uh, two different kinds of tail kind of thing. So we put some tail over where you will mention the specifications. So I'm mentioning the specifications over here, and there are different kinds of process specification, right? So you can put some flag over here to interpret that this is a field symbol. Then So then you can have some kind of symbol like uh, all around. If you are doing some all around weld, then you put some circle over there, right? And in terms of specification, what you need to mention, there are three things over there. So those three things are L, P, and D. What are these three things? L is your length of the weld, P is your pitch of the weld. If you are doing multiple welds over there, you need to mention the pitch of the weld. And another thing is the depth of the weld. These three things are very important to mention for any kind of weld job, you know. And what is this called? This is called weld line, correct? Now, these arrow side of the joint, that should be written in the bottom part of this reference line. So if this is my reference line, if this is my reference line, and let's say I'm doing some V-butt joint like this, and my arrow is provided over here, and I need to provide the specification at the bottom part of the joint. Sorry, at the bottom part of this line. And if it is far side information, you should put it on the over of this line, right? These are the standard practice, which is uh, what should I say, which is maintained in any welding industry. Now, yeah. So after that, what more you need to mention over there are three things. So let me rub it up. So what more you need to mention over here? You can mention three more things, F, A, and R. What are those? So if you are doing, say, V-butt joint like this, I'm doing V-butt joint. What is this distance called? This is my root opening. So R is interpreted for root opening of the joint. F is known for the finish of the joint. If you are doing this butt joint, then this is my groove angle. So A stands for my groove angle for edge preparation, right? And also you can put some kind of contour over here. So either it can be convex contour or it can be concave contour, that I am coming later. So if A R, those three things are those are also three different important things which you need to mention for your weld joint geometry. Now let us uh, let us have some examples of let us have some example of this weld type and what would be the symbol for those. So I have mentioned few of those weld joint over here, and we need to figure out how will it look like in terms of sectional representation and also in terms of weld symbol, right? Now, how will it look like in terms of bevel group? If you are having some bevel group joint, how will it look like? So we have already done this in our earlier lecture. So this will look something like this. This is my bevel joint, bevel group joint, and the symbol will be like this, right? Now for J group joint, how will it look like? So for J group joint, so let us say J group, how will it look like? So I will have some edge preparation like a J shape over here, and another will be a simple rectangular joint, right? This will be a J group joint. And what will be the symbol for J group joint? How will it look like? So my J group joint will look like something like this. So this is one of the edge and this is another edge, right? This is how it will look like. Let's say this is some kind of flare bevel group. If this is flare bevel group, what will be the symbol? If this is my edge, another edge will look like something like this. So this will be the weld symbol for flare bevel, right now. Now what will be the symbol for a fillet joint? So let's say you have a fillet joint like this. So you have done fillet over here, and this is my arrow site. So what will be the weld symbol for a fillet joint? It will look something like this, a 90-degree triangle, right? Then you have few more extra symbols like as I was saying in the weld joint specifications. You can have those field weld, or you can have weld all around, or you can have those backing or spacer kind of thing, or you can have melt throughout. So for each and everything, you there are different kinds of weld symbols. So let us go through those one by one. Okay, why don't we finish the question part number one? So for J group joint, I talked about this. I have also done the sectional representation for fillet weld. I have also mentioned the sectional representation. And what about the V group joint? How will it look like for my V group joint weld symbol? It will look some kind of V in nature, right? And then I was mentioning that there are few extra symbol parts. So those are, you can have field weld, you can have weld all around, then you can have backing or spacer, then you can have melt through, right? So my field will be some kind of flag for weld all around. It will be a circle all over. For backing, this is something like this. So either this or this one. This is for if you are using a backing or spacer material. And then you have those melt through. So for melt through, how will it look like? This will look like so something like this. right? And then you have those, so what does it mean through male through? So if you have a V butt joint like this, and let's say this is the deposition geometry. So this portion, the top portion, that is called my top male through, and this portion, this is the bottom portion of that male, right? Then you have some other welding symbols for fillet weld. Then I was talking about in my earlier video. So we have fillet weld, plug weld, spot weld, seam weld. So every kind of weld geometry will have different welding symbols. So if we talk about, let me look this up. So fillet weld, anyhow, I have talked about fillet weld. So the symbol will be something like this. Then we have this plug or slot weld, where the weld symbol will be simple rectangle. For spot weld, the welding symbol will be a circle, and for seam weld, this will be circle with two parallel lines. So that's how it will be signified, or it will be identified, right? So those are few of my welding symbols, and uh, then I was talking about uh, that arrow side and the far side, right? So let's say this is my T joint like this, and my arrow is provided over here. So which one will be the arrow side and which one will be the other side or far side? So the closest location for which this arrow is the joint. If whatever joint will be done over here, if this is a fillet joint, then I will provide the fillet joint specifications in the arrow joint portion, which should be mentioned at the bottom part of this reference line, right? So this is the arrow side, and the top part will be the other side or far side. So these are few things which we need to remember. Now let's say this is a lap joint specification, and I have provided arrow over here, as this is the closest side of from this arrow. This side will be my arrow side, and this side. So if this is 2, this is 1. 1 is my arrow side, 2 will be the far side. है ना? Now let us again do some uh, exercise on finding some welding symbols so that it will be understandable, and at the same time it will be simple to do. So before that, uh, we have some weld symbols. We need to draw some weld symbols. We need to draw some weld symbols for these three of those weld specifications. So first one said we have this fillet weld where you have this 2 mm leg length on arrow side, and you have 8 mm leg length on the other side. So how will it be, the symbol, how will it look like? So I have not mentioned this what kind of joint it is. So let's say I want to do some T joint over here where I am doing some fillet weld, right? So if this is a T weld, so let's say this is the answer for A. So if this is a T joint, this is my T joint where I have, let's say, fillet over this location, right? And this is where I have provided this arrow over there. So it says that you have fillet weld of 2 mm leg length on the arrow side and 8 mm leg length on the other side. So what you need to mention over there then? You will mention 2 mm leg length on the arrow side, right? Which I need to specify at the bottom part of this reference line. And if you have this 8 mm leg length, that will be on the other side, right? Now, that's how it will look like. Then you have some butt weld with the open square weld on arrow side. You have a butt weld with the open square weld on the arrow side. So you have a butt weld. Let's say you have a butt weld like this. And for open square weld, if this is the location where which one will be the arrow side, this will be a simple parallel, two parallel lines for an open square weld. Correct? This is what I have talked about. Now, if it is a V butt weld, if it is a V butt weld, in case of parallel lines, you had to put those V over there, right? So if it was a V butt weld, you had to simply put that V symbol over there. Then I have talked about, so this is my B, and what I have talked about in C is fillet weld of 10 mm leg length for weld all around. So I will do a fillet weld. So let's say this is, I want to joint the all around weld. So if this is my arrow side, I will simply put that circle all around uh, to identify, to understand that I want to create a all around well over there. And whatever leg length you will mention over there, you will tell that. So if this is 10 mm leg length, I will tell that this is my leg length and this will be a fillet weld with a weld all around, right? Any question till now? Okay. So if we have no question, I have created one joint geometry over here, and we will try to figure out what will be the weld symbol for this. So here we have a T joint. What we have over here? So we have a T joint. So one of the side it is having fillet weld. What is the other side? My other side is a bevel group joint. So this side, this Let me take the green one. This side is the bevel group side. You know? And this side is my fillet side. So we have covered that whenever there will be those multiple number of multiple number of operation. So in case of sequence of operation, the first operation which will be closest to the arrow, that need to be mentioned first, right? So I have mentioned, so I have not mentioned anything as such over here. So let's say fillet weld is my first operation. So I am saying that fillet weld is the first operation, and this bevel group joint is the second operation, right? So if my first weld operation is fillet weld, I will put those specifications over here, right? So if you have some sequence like this, let's say you are doing some open square joint like this, and you have some symbols, you have some symbols like this. So this is my melt through. This is my um, fillet one. Sorry, V group one. This is my fillet. So this one will be my first operation, which is closest to the arrow, right? So this will be my first operation. This will be my second operation, and this will be the third operation in terms of sequence, correct? In the same way, we will try to figure out what will be the joint symbol over here. So what else do we have for the fillet weld? So for fillet weld, we have this um, we have this weld depth, right? So we have this weld depth. This is my weld depth, right? I have not mentioned what is the fillet size. Let's say this is, I am doing some 3 by 5 inch weld size, where my weld depth is 4 inch, and let's say my leg length is 5 inch. So I'm making some random specifications over here to just to understand what will be the joint symbol. So these are the specifications for my fillet weld. Then for bevel group side joint, what are there? You have this weld depth again. You have this weld depth for bevel group. You have weld depth of 4 mm. Sorry, 4 inch. Anyway, whatever will be the unit, that should be the consistent one, right? And then what is this? This 1 inch. This is my bottom reinforcement of melt through, right now. So this is my bottom reinforcement melt through as 1 inch. And what is this? This is my groove angle as 50 degree. Correct? Now in terms of joint geometry, how will it look like? So if this is my arrow, I will tell in the arrow side So this will be the arrow side which need to be, let's use some different colors. So if this is my arrow side, I will put this as the fillet weld symbol. Then my leg length will be 3 by 5 inch, and also I will mention those. Sorry. My fillet weld size is 3 by 5 inch, and I will also mention those 4 inch as leg length and 5 inch as leg length and 4 inches weld depth over there. And on the other side, which is my second operation, so other side will be mentioned at the top of this reference line, correct? So it will having a mailed through, which I have kept as 1 inch. Then this is a bevel group side joint, which is having some groove angle, which is having a depth of 4 inch and a 50-degree groove angle. Now let's say you are having some weld specification which is provided for a first weld or second weld, whatever it will be mentioned. Let's say this is for second weld specifications. So, so I am providing CJP as my second weld specification. So you need to put the tail over there and mention it as CJ for that weld symbol. So that's how we'll do for different weld geometry. There are few extra things like you can have straight arrow lines, you can have broken arrow lines. So straight arrow is basically used for the weld location, whereas that broken line mainly used for joint preparation, and it basically breaks towards the piece that is to be beveled. So if you are having some bevel kind of joint, uh, you 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 use that broken arrow line where towards the piece where you are doing that beveling.
Hello.
Yeah.
Fillet weld symbol first मतलब operation first operation तो left side vertical line not so arrow
Okay.
side
Mm-hmm.
uh,
So this is my arrow side.
arrow side but fillet weld so vertical line is always left side na.
Acha, you mean to say like this?
Yes. नहीं नहीं wrong left vertical line हाँ
You mean to say like this?
opposite of मतलब हाँ yes
Right?
yes fillet मतलब fillet triangle okay
That's what I did, I think. Okay, yeah. So if my fillet is in this way, you have to put this line as this. If my fillet in the other way, you have to put it like this. So if my fillet was in this direction, you had to put the fillet like this. Am I right?
नहीं always fillet मतलब left line is मतलब always vertical line is the left side not right side
Okay.
and above second operation uh, सिंगल वी के फ्लेयर बीवेल मतलब बीवेल ना वन टाइप ऑफ मतलब सिंगल बीवेल
So I've talked about a single bevel, not a flare bevel over here. So for
ओके
flare bevel, there are different symbol. Yeah. In terms of world representation, this is a little bit similar kind of thing for flare bevel and normal single bevel. Correct.
Okay, thank you.
Yeah. So, as I was talking about in terms of that straight arrow and broken arrow line. So let me talk this up. So let's say I had a Weevil group joint like this. So this is, it's a 30-degree, and the length is, I don't know, maybe some 0.5 inch. And so I'll put some opening over here, which is, let's say, 1 by 6 inch, right? Now, in terms of that broken arrow line, where I want to show that towards the Weevil group joint, I will show it in this way. So over here, I'll put a broken arrow line, and then I will have those. This is my Weevil specification, and then you will have that length as zero point 0.5. Then you over here you need to mention the angle, which is 30-degree, and also that the opening, which is mentioned as 1 by 6 inch, right? That's how we will provide for a broken arrow line. Now, few things over here we need to remember is like, if there is nothing mentioned in terms of depth, so it will tell us that the bevel goes all the way to other side. So it will be, so like if you have a butt joint like this, the bevel is all over the thickness if there is nothing mentioned in terms of depth, right? Another thing is like, your throat measurement should be given on the left of the weld symbols. So these are few things which you need, which we need to remember every time to have some proper understanding of that weld symbol. Yeah. Now let us move to that this power source thing. Uh, yes.
Fillet symbol show in the first मतलब first operation is till now wrong मतलब अबे 4 4 inch by मतलब /5 inch is left side ना.
Can you come again?
1 minute 4 5 is okay मतलब L or P length of the weld or pitch of the weld 3 by 5 is the depth but symbol draw is fillet first operation is wrong ना मतलब left side vertical is okay फिर then bottom two or triangle touch line. Yes, bottom two.
So you mean to say,
Yes. Yes, right. Yes, this is correct.
is it
Yes.
right now?
Yes. Thank you.
Yeah, I made some mistake. Correct, correct. Okay, so what we will move now is to this power source thing. In terms of question, I'm coming later. Let us have some discussion on in terms of these mechanisms and some open circuit voltage, short circuit current. We have some numericals to cover also. Um, so initially we'll talk about these theoretical things in terms of categories of power source, some brief discussions, and then we'll move to the this numerical part. So yeah, in terms of these electrical discharges, we know that there are different three different categories of electrical discharges. You know, so you have that you have this spark discharge, which is of high voltage and low current. You have something called glow discharge, where you will use medium level of current and medium level of voltage and a little bit of low amount of current, and this is also sustainable in nature. And another thing is arc discharge, right? So you'll have this low voltage and high current over here, right? So what we have in terms of power source, it will be something look like this. So let me explain over here. So let's say I'm having an electrode like this. So this is my electrode and this is my workpiece. So one end will be connected to the positive end and one end will be connected to the negative end. And from where I will create the arc. And this is my electric source, right? Now how does this arc generate over here? I will come to different classifications of this electric source in terms of DC, AC, in terms of rectifier, inverter. You have different kinds of power sources over here. Uh, Before that, we should understand like how does this electric arc generate. So there is something called thermoionic emission. Have you heard of this term, this thermoionic emission?
No, 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 no. First time.
Okay, yeah, okay. So what is thermoionic emission is basically, okay, before that, uh, what is a heat source? So basically your heat source should release some kind of heat in a in a sharply defined zone, right? It will which will be isolated in nature. Now this can be an electrical, like what happened in your shielded metal arc welding or MIG, TIG, those kind of operations. It can be some kind of flame in terms of gas welding. These we have already talked about in our earlier lectures, right? And also this can be some kind of exothermic chemical reaction, right? In place of thermit welding, there will be those exothermic chemical reaction. Now, as I was mentioning, we should understand that how does this electric arc generate and is maintained between those two electrodes of opposite polarity. So you have one is positive polarity, you have that negative polarity, right? Now here in this figure we have schematically shows that electric circuit which is used for this arc welding. Now over here I have put workpiece as the positive electrode, right? So my workpiece is positive electrode, which is also called as anode. and the electrode, this rod, the electrode rod, that is my negative electrode, which is also called cathode, right? These are known things. Now, what happens is, initially you have to provide a good contact between that electrode and workpiece. So whenever you do some welding, you will initially do some good contact between electrode and workpiece, and thereafter that electrode is withdrawn. And what happens as a result, that initially the metallic bridge which was generating because of that contact between electrode and workpiece, uh, that bridge will start to break. And because of breaking that metallic bridge, you will increase the current density per bridge. So basically, whenever you provide that contact, you are creating a metallic bridge. And whenever you are basically removing the electrode from that contact, this bridge is getting disconnected, and it will increase the current density, right? And it rises to such a high value that it can start boiling also. And under such conditions, the electrons come out of both the surfaces by the process called thermionic emission. So this process is basically electrons come out from both the surfaces of cathode and anode, right? Now, obviously, the electrons coming out of the anode, which is positive in nature, those are pulled back, and whereas those coming out of the cathode, those are also attracted towards anode, है ना?
Yes, yes.
Right? Now, so basically, because those electrons are getting attracted towards anode and those are pulled back, there will be some kind of interparticle collision. There will be some kind of collision in between those electrons, right? And what will happen, that gives rise to a process called thermal ionization. So normally these collisions are elastic, and both the momentum and kinetic energy, obviously, those will be conserved. However, occasionally a collision is such that an electron may be completely knocked out from the neutral atom, so it can produce a free electron and a positively charged ion, right? And such a collision, of course, which is not elastic in nature, right? So those kind of ions will then produced and attracted towards the cathode, and yeah, that's how I already explained, those free electrons will move towards each other. So two things is important over here. One, the process of thermionic emission, and the part thermal ionization. There are different kinds of arc structures, characteristics, maybe we'll cover in later part. And yeah, there is some voltage current relationship for your power source always. And maybe we'll cover in the we will cover in that in the later, when we'll discuss the arc welding in much more detail. Okay, so in terms of power source, what we have in terms of power source, what different kinds of sources we have. We can have some welding generators. We can have some transformer. We can have some rectifier also. Also, we can have an inverter, right? This can provide you both AC or DC. Welding transformer always provide you the AC current power supply. Welding rectifier also provides you AC, and the inverter will always provide you a DC power supply. Correct? Now there are some concept called open circuit voltage, OCV, and also there is something called short circuit current. Okay, what is open circuit voltage? So when there will be no load or no current is applied through your welding electrode, or there is no current in between electrode and workpiece or positive negative terminals, uh, at no load condition, the voltage that appears at the terminal is at its maximum. So at no load condition, the voltage at terminal is called as OCV, or open circuit voltage, which always will be at its maximum. Now, this high OCV value generally uses this starting of the arc, and it provides you the stability. So your welding voltage will always be less than the open circuit voltage. Open circuit voltage will always have those high values to provide that stability in your arc. Now in transformer type power sources, those OCVs established by um, some incoming line voltage, and some there will be some kind of primary secondary windings in your transformer, and based on those ratios you will have that voltage, and based on that you will generate some open circuit voltage. So in general it normally ranges between 70 to 90 volt for this transformer, and for this rectifier. So this is for welding transformer, and for rectifier it will be somewhere around 50 to 80 volt, right? Okay, so this is on this OCB and S. Okay, I did not talk about this short circuit current. So basically, short circuit current is during the short circuit transfer mode of welding. What will happen is like when your electrode touches that base material, it effectively creates some kind of you know what is short circuit. So as I was telling now, initially you have to contact that electrode with the workpiece, and then you will uh, retract that electrode from the workpiece surface. Whenever you will create that contact, it will generate that short circuit current, and then it will break that metallic bridge to increase that current density, so that arc will generate over there. Okay, and then we had some concepts on this DCEP and DCEN. Can you tell me what is the full form of DCEP and DCEN? What is DCEP? It's electrode positive. DC electrode positive and DC electrode negative. So there are specific application when you should use DCEP, when you should use DCEN. Yeah. Now when the welding process is, so basically over here we perform our welding operation in DC mode, of course. And what happens is always two-third of heat. These are some thumb rules, right? These are some thumb rules. So approximately two-third of the heat that generates at positive end or the anode, you can say due to some impingement of high speed or high energy electrons, right? Because anode is attracting the electrons, so high kinetic energy of electrons, most of the heat is getting generated at the anode, whereas one-third of the heat that gets generated at the cathode portion. So, so this high speed or high energy effect, the negative cathode does not experience that effect and can even undergo some kind of cooling by this thermoionic emission dependent on your material. So yeah, I have mentioned these thumb rules. And then as I was talking about this we have welding generators, transformers, rectifiers, inverters. So generators are very popular for many kind of years. So they provide you high cost, but the efficiency is poor over there. However, the welding characteristic has been excellent for this motor generator power source. In general, they consist of this three-phase AC motor, and that is coupled to a DC generator. So you have a motor like this. You'll have a motor like this, where you'll have this supply from here. So that will be a AC motor, which will be connected to a generator. So you'll have those. This is my workpiece where I will create that arc. Right now, depending on which engine this generator powers up. So welding generator power units, that those are driven by some kind of petrol engine or some kind of diesel engine, right? Those are still made. So yeah, they exist always. And then you have those AC power sources. So what happens with AC? Let me dump this up. So after this, a little bit talk about this AC power source. We'll try to do some numericals over here. So they are very simple numericals. I have kept it simple to do it in this restricted time. So yeah, what is there in AC power source? So AC is a popular choice for the fact that it uses some simple and inexpensive power unit. So introducing AC that lead to a complication because unless you do not provide some special steps, the arc will extinguish on zero crossing, right? It will the current will always have some fluctuations like this. So this is my zero crossing. So until and unless you provide some special steps, that arc can extinguish. The stability is very poor over there, the arc stability. So the need to reignition. So we have to reignite the arc, right? That requires a sufficiently high OCV. So this requires a high open circuit voltage, almost nearly to 50 volt. Now, there are some advantages also for this AC power source. What are those advantages for AC? What are the advantages of using alternating current? So you can have something called reduced risk of arc blow. So you can basically, because of using those alternating current, you can somehow control those arc blow effect. And also, in general, people use for this oxide breaking performance. So always you will have those surface oxides on any kind of metal surface. And AC is very useful to break those oxides because of alternating nature. Oxide breaking performance. In generally, in terms of if I want to talk about some example, we can do TIG welding for welding of aluminium with the AC power source. Aluminium oxide is very stable in nature even at room temperature. No? So yeah. Now for AC welding, the power source is always a transformer with a control for you can have some control for a current adjustment either by varying the inductance or you can change some magnetic coupling between those primary and secondary windings. So your transformer will have two kinds of windings, right? You can have a primary winding like this. So the coil will have a specific number of turns and you will have a secondary windings. So if this is number of turns of the primary coil, if this is number of turns of the secondary coil, we know that from the Faraday's law, voltage at that primary side will be NPT phi dt, where phi is your magnetic flux, and based on that, it will follow the relation of this. So based on this formula, we'll have some numericals also, right? So now for changing the inductance, what are there in terms of different kinds of reactors? So there are something called tapped reactors. There are something called moving core reactors. There are something called saturable reactors. So we have gone through this in the lectures, right? Saturable core reactors. Okay. Uh, Before explaining those things, let us try to do some numericals. So, yeah, we had already discussed in question 3. Now I have talked in question 4 in terms of suitable electric discharge used for welding. That will be an arc discharge. That we know. We have already talked. Now let us do this numerical. So it says a battery having an OCV of 2 volt, which has a terminal voltage of 1 volt, and when I am supplying a current of 5 amp, what will be the internal resistance? So I have a OCV of 2 volt. I have a terminal voltage of 1 volt. I am supplying a current of 5 amp. What will be my resistance? So I know I equal to V minus delta V by R, where let's say V is my OCV at no load condition, and when I'm applying current, the terminal voltage is the 1 volt one. Can you give me a value? What will be the resistance over here?
One by five.
How much?
1/5.
1 by 5. So my internal resistance of the battery is 0.2 ohm.
2 ohms.
Okay. So can we do this one? So I have talked about that uh, welding transformer in terms of primary and secondary windings. It says that in a step down transformer, the voltage across the primary winding is 240 volt. So V primary is 240 volt and number of coil turns is 120. Now I want a desired voltage out of the transformer which will come out from the secondary winding, that I want a 40 volt. So what will be the number of coil turns in the secondary winding side?
I think 40.
I think it is 40. So Vp by
Vs is
is
equal to
Lp by
Np by
Ns.
Ns.
So
120
240 by
by
40.
40. Sorry. 120 by 40.
So
For
6
6 for
Ns.
6 into Ns is equal to 120.
20. Ns is
620
20.
is 20. Yes. Hmm.
So my secondary winding coil side will having 20 number of coil turns, right? Those are very simple. Then I have some question on this DCEP and DCEN, direct current straight polarity and direct current negative polarity. What is the polarity? So your electric circuit that is created when you turn on the welder that has a negative and positive pole, right? That property is called a polarity. Polarity matters greatly in welding because choosing the right polarity affects the strength and quality of the weld always. As I was talking about what is straight and what is reverse polarity. So this is in common terms of electrode negative and electrode positive. So electrode negative, let me look this up. This is a standard practice of electrode negative. We call it as straight polarity, and electrode positive, we call it as reverse polarity, right? Now, welding currents with electrode positive polarity that results in a deeper penetration. So weld penetration depth will be deep when you will use a reverse polarity. Because of that, I was talking about that two-thirds of the heat will generate at the anode and the rest amount will be generated at the cathode because of those kinetic energy of those electrons, right? Impingement of the electrons over there. So in reverse polarity, you will weld penetration depth that will be higher compared to the straight polarity. Now, what is the advantages of a straight polarity or a negative polarity? That is having an advantage of faster melt off and faster deposition rate. These are my advantage of straight polarity, right? So what will happen over here? My straight polarity will be used for
B3, B4,
joining thick sheets and used for
B4
non-consumable electrodes,
electrodes. Direct current reverse polarity is to join the sheets.
right?
Electrodes are consumable.
So reverse polarity is used when you want to join thin sheets.
Yes, sir.
And over here, your electrode also will be consumable in nature. है ना? Okay, so let's move to this numerical. This is a little bit lengthy in terms of, yeah, you have to do some calculation, some rigorous calculation over here. So you have talked about this OCV and short circuit current, right? They follow an equation in terms of voltage current characteristics as V by OCV plus I by SCC, that equals to 1. And always your voltage will follow a relationship with your arc length as V, as a linear relationship. So if this is my weld voltage and this is my weld arc length, So if my arc length increases, voltage will also get increased. If arc length decreases, voltage will get decreased. They will follow a simple linear relationship. So here it says that, so this is, I have provided you some brief introduction. Now here it says that the voltage length characteristic of a DC arc is given by this equation, which is V is equal to 20 plus 40 into L, right? Where L is the length of the arc in centimeter. Then it says that the power source characteristic is approximated by a straight line with a function V by 80 plus I by 1000 equal to 1. So V by OCB plus I by short circuit current equal to 1. We have to determine the optimum arc length. So L max we have to determine. How we can determine the optimum arc length? What we will do to do that? So I have a equation of V by 80 plus I by 1000 is equal to 1, right? So if we want to convert voltage in terms of current, what I can write it down? V is equal to, so voltage as a function of current, I can write it down this from this equation, right? So this is simply 1 minus, I am putting I by 1000 at the right hand side and then multiplying it with 80. Then I have mentioned V is equal to 20 plus 40L. So this is my equation 2. Both these voltages are same. So I will equate these two equations. 80 minus 80 by 1000 into I, that will be equal to 20 plus 40L. So what will be my I from here? I will be, okay, 80 by 1000 I is 80 minus 20 minus 40L. So I is equal to 60 minus 40L, this into 1000 divided by 80 amp,
80.
right?
Mm-hmm.
Now what is my power? Power is voltage into current,
Voltage current.
correct?
Yes, sir.
So my power will be 20 plus 40 into L. I am basically converting power as a function of arc length because I want to get the maximum arc length.
Okay.
So this will be 20 plus 40L, that into
60
60 minus
minus
40L
40 L
into 1000 by
80.
80. This is in volt ampere or watt, whatever you say, right?
Mm.
This is my power. Let me round this up. So if this is my power, which is a function of arc length, to get the maximum power, what we need to do? We need to have some derivative, which will be equal to 0. That's how
Okay.
we get the minimum or maximum value. right? So you have to derivate, you have to do the derivative of power in terms of arc length. Can you do that quickly?
Yes, sir. Sorry,
Mm-hmm.
I don't know about derivatives. Let you explain.
Okay. So,
I didn't remember, sir. Actually,
okay. So, what is power over here?
power
Uh,
is equal to 20 plus 40 L.
this is 1000 by 80. This into 1200 minus 800 L plus 2400 L minus 1600 L square. Is it not?
Okay, sir. Fine.
Now, this is 1000 by 80 into 1200
Right.
plus 1600 L minus 1600 L square,
That's good.
right? So,
Uh,
this will be something around, I don't know how much this is coming. So, these are the constant terms. 1600 into 1000 by 80 L minus 1600 into 1000 by 80 L square. So you have, let's say this is A, this one A plus BL minus CL
right.
square. So your dPdL will be B minus 2CL. So as this is constant, the derivative with respect to L will be 0.
Okay.
The derivative with respect to L will be this one, B, which is this one. The derivative of CL square is
Yeah.
2CL, right?
Okay. Okay. Square two into
Yeah.
um,
So that you need to equate with 0 and then get the value of L.
into zero.
So you can do some uh, exercise over here. So your L should come around 0.5 cm. And whenever you get the arc length value, you will put that in this power value to uh, get the arc power. So my power is a function of length, right? I
Hmm.
get the optimum length as some 0.5 semi. You put the 0.5 semi and in this function to get the optimum power. So my P optimum should come around 20 kilovolt ampere. Just confirm that these two answers are coming or not. Yeah,
Okay, sir.
yeah. So we have another question on this heat input per unit length. what is heat input per unit length? Heat input per unit length is basically the heat flux which is getting in Q. This is my welding heat flux. That divided by the, what is V? Welding speed. Can you tell me what is the unit of heat input per unit length?
No, sir.
The unit will be joule per mm. So your heat flux will be some joule per second, and your welding speed should be in mm per second. So your heat input per unit length will be in unit of joule per mm. Now, what does this question say? It tells me that uh, for a TIG welding process, my arc current and arc voltages are provided. So I have, before that, welding heat flux is mainly the welding power which is coming in. That is voltage into current, right?
Mm-hmm.
Now it says that the current for this
300.
TIG welding process is 50 ampere and 60 volt when
Mm.
the welding speed is 150 mm per minute. In another process, the welding is carried out at a welding speed at 120 mm per minute. So for the second case, I have provided this welding speed at the same arc welding voltage. Now I say that if the heat input per unit length to the material remains same, so Q by V remains same. So I am saying that Q1 by V1 is equal
V1,
to Q2 by V2,
V2.
correct? Then
Okay.
I have to determine the welding current for the second case. What will be the I2 value? So if Q1 by V1 is Q2 by V2,
This is after
so
one.
it's basically V1 I1 by V1 is equal to V2 I2
V2,
by
I2 by V2.
V2. Then I
V1,
say
I1.
V1 is equal to V2. I say that at the same arc welding voltage I am doing the
Uh-huh.
second case.
V1 is equal to V2. You
So
can
I
say.
can, yeah. So I1 by V1 is equal to I2 by
V2.
V2, right?
Uh-huh.
So 50 ampere by
60.
150 mm per minute is
V1 speed.
I1 by
V1 speed.
120 mm per minute.
120.
So
I2
how
is
much this
equal
is
to
coming?
1 by
It's 20,
1 by 3. 3 is 40.
40.
40.
40 it is, right?
Yes, sir. 40.
Okay. So yeah. Finally, we have some question on this duty cycle. What is a duty cycle?
Duty cycle. Duty cycle is 20 amperes. Duty cycle.
So
Complete
duty
welding
cycle
process.
is basically the ratio of your
Duty
arcing
cycle.
time to the weld cycle time.
Ratio of the
Duty
duty
cycle,
cycle.
ratio of the arcing time
uh,
to the weld cycle time,
Weld cycle. Achha.
right? So weld
Mm.
cycle time will both include that arcing time and the time when the arc will
Delay. Delay time.
be off basically. Arc will be off at that time, right?
Yes,
Now,
sir.
welding cycle time, so there are different standards. which is followed by these European standards or these American standards. So
American
welding
standards.
cycle time is either 5 minutes as per European standard or 10 minutes as per American
10 minutes
standard.
in American standard. Yes, sir.
So they follow that standard time of the cycle time. Now, if working time is continuously 5 minutes, then as per European standard, I will call it 100% duty cycle because they follow the complete time as 5 minutes. If it is continuously 5 minutes for arcing time as per American standard, because uh, they follow 10 minutes as the world cycle time, it will be as 50% duty cycle time, right?
Yes, sir.
Now, the welding current which can be drawn at a duty cycle, that can be evaluated from this equation. dr into ir square, that will be duty cycle at 100% into this is my equation through which I can implement the welding current which can be drawn at a duty cycle. So if my question says if the current at 100% duty cycle is 250 amp, what should be the required current for 50% duty cycle? So this is my 100% duty cycle
Mm-hmm.
and this is my current
Current
at
square.
100% duty cycle.
Square.
Now uh, I want to get the value of the required current for 50% duty cycle.
Square. Okay.
So what will be I?
25 into 25.
So for me, this is coming something around 8.
6 to 500 to 0.1. 6 to 50. 6 to 50 of 31. 3125. I square 3125 का टू करना है. Root of 3125.
Are you getting it?
No, sir, one minute.
Hmm.
3125. Hello.
Yeah.
Sir, 559 आएगा.
कितना?
Double five point. Double 5.9.
Double five
0.9.
55.9. So
हाँ,
250
actually
square.
0.1 into 250 square आके
Yeah.
6625 आ रहा है. 6625. इधर
6250.
6250.
250 square into 0.1. This is
हाँ,
6250.
6250. Okay, okay. Then 3125.
divided by 0.5.
3125.
Divided by 0.5. That is 12,500.
Okay, sir. Fine.
Not 5.
Okay, sir.
And then square root of 12,500.
Hmm.
So basically, to understand the duty cycle, if you say that 400 ampere at 35% duty factor or duty cycle, what does this
R.
mean is uh, your power source can supply 400 ampere for 3.5 minutes or in every 10 minutes. So if you are having duty cycle as 35%, let's say. So I am saying that my power supply can supply some amount of, so if I am saying that this is 400 ampere
Okay.
at
Hmm.
35% duty factor, so I'm saying that it can supply 400 ampere for 3.5 minutes in every 10 minutes. So
Okay.
3.5 by 10, that is 35%.
Okay.
Okay, so we'll stop over here. Again, meet next week.
सर अभी ये वेल्डिंग के बारे में
हम्म,
क्वेश्चन पूछ सकते हो ना?
वेल्डिंग के बारे में अब तक
नहीं
मतलब
नहीं.
हम घुसे ही नहीं उतना डेप्थ में. देयर आर डिफरेंट काइंड्स ऑफ वेल्डिंग ऑफ कोर्स. फिर भी
हाँ.
पूछो, पता नहीं, देखते हैं.
मेरा क्वेश्चन क्या है ना, अभी उसको भी इलेक्ट्रिकल का इसमें जा रहा है.
हम्म.
इसको वेल्डिंग का रिलेटेड है क्या, मतलब जो भी जा रहा है प्रैक्टिकल से यूज होगा या नहीं यूज होगा बोल के, जो भी कैलकुलेशंस जो भी इलेक्ट्रिकल का पावर सोर्स जो भी वो बता रहा है,
Yes,
इसको भी.
means I don't know if you have done this welding lab or in your institute or not, but
एक्चुअली आई
every
एम जॉब होल्डर सर.
means in each and every industry, whoever does this fusion welding in terms of doing this arc welding, you have to have some knowledge of these power sources in terms of what kind of voltage current relationship it follows, what are the different components of your power source, like sir was talking about this rectifier, inverter, uh, to understand the power source to create that voltage, required amount of voltage and current, you have to, yes, you have to understand. मतलब इंडस्ट्री में काम तो आएगा.
ओके सर, थैंक यू.
So yeah, means whatever there in the content, there is something in mind in you can connect when if you go to industry, you can connect those theoretical background. ठीक है.
ठीक है सर, थैंक यू.
Okay, thank you. Bye.
बाय.